Hey, we're going to make a video here of a couple of examples of power series. So this will be your hybrid instruction for the weekend. It's 4 problems. I'm going to do 2 of each problems. These 2 say find the function the power series converges to and identify the interval and radius of convergence of each series. And again, we're using the fact that if I have a sum from n equals 0 to infinity of a to the n, that is going to equal 1 over 1 minus a on the interval of the absolute value of a less than 1. So here we're given the 2 series. In both cases, we have to get something to a power n before we can use this formula, and then find the interval and radius of convergence. The next 2 problems are going to be going the other way. We're going to be given the function. We're going to try to rewrite it in this format, 1 over 1 minus something, or 1 minus a, and then that will allow us to get the power series going and the radius of convergence. And we're going to go backwards, given the function, determine what its power series is and what radius of convergence that would be. Okay, so this first problem, sum from n equals 0 to infinity, 2x minus 3 to the n. Quickly share a whiteboard here instead. And I would encourage you to just do this problem along with me, and you'll have it in your notes. We are looking at the sum from n equals 0 to infinity of 2x minus 3 to the n. And so good news is we already have the a to the n here. So we can then say, okay, this equals 1 over 1 minus all of that. The all of that is the 2x minus 3. It's like this pen is a little bit too thick. Okay. 1 minus, there we go, 2x minus 3. And that converges on the absolute value of whatever's inside those parentheses is less than 1. And the value inside those parentheses is 2x minus 3. We're essentially done. We just need to simplify this fraction. 1 over 1 minus 2x plus 3. And then I can combine the 3 and the 1 to get 1 over 4 minus 2x. So that's the function that this power series converges to. On what interval does it converge? Well, I'm going to put whatever's inside there between -1 and 1 in an inequality to get rid of the absolute values. And then we just solve this inequality, add 3 to all 3 sides. We get 2x sandwiched between 2 and 4, and then divide by 2 to get x's between 1 and 2. So on the interval from 1 to 2, that's the interval of convergence. The power series equals this function. And then what's the radius of that interval? Well, it's the total distance of the interval divided by 2. So, that total distance is 1. So r is 1/2. Where do I get that from? You can always say, it's the distance, 2 minus 1 over 2. Again, that's a half. Okay, so that's the first problem. I'm going to maybe just stop this guy and go on to the second problem. There we go. Okay, second problem is B. And again, I would just write it down. The sum from n equals 0 to infinity. -2 to the n. So that's to the correct power, times 1/3 to the n plus 1. So that is not to the correct power, times x to the n. And that again is to the correct power. So our goal here is to write this as something to the power n. Well, this is the guy here that's not to the power n. So what is 1/3 to the n plus 1? That's the same as 1/3 times 1/3 to the power n. My cat's giving you a cameo tail there. There she is. Okay. How about that? So I'm going to rewrite what's inside the sum. The sum from n equals 0 to infinity. I'm going to pull this 1/3. Really, I can pull it all the way to the front because it's a constant. It's multiplying all the terms, so it's not depending on n. And then we'd be left with a -2 to the n, a 1/3 to the n, and an x to the n. So I can then bring all of those inside the sum, 1/3, the sum n equals 0 to infinity of all of this to the nth power. And if I multiply those bases together, I get -2/3 x inside these parentheses. And then I have what I want. I have this thing a here, a to the n. So the formula allows me to, okay, so this 1/3 is out in front, and then this part is 1 over 1 minus a, 1 over 1 minus a, and the a here is -2/3 x. And essentially, we're done there. That's the function, but we want to simplify it, and then we want to know on what interval of x's are these two things equal. So that has to do with the convergence. I'm going to multiply the tops here and get 1, and multiply this 3 through the bottom to get 3, and this is negative and minus plus, and 3 times 2/3 is 2. So 1 over 3 plus 2x is our function that this power series is equal to. And then I need that a, which is -2/3 x. The absolute value of a, -2/3 x, has to be less than 1. So when I solve this inequality, I'm just going to get rid of the negative because I take the absolute value. I can just ignore that negative, get rid of it, and put 2/3 x between -1 and 1. This is much better. If you can leave the negative and then same thing, but the inequalities will flip. You'll get the same result. The inequalities would flip here if I had to multiply by a negative, but I don't because I just ignored it. Taking the absolute value of a negative becomes a positive. Multiply all three sides by 3/2, you get -3/2 is less than x is less than 3/2. So on this interval, this power series equals this function. This is the interval from -3/2 to 3/2. You know, when it's centered at 0 like this, the radius just equals the 3/2. It's the distance from 0 out. So that radius here is 3/2. I'm going to stop this video and I'm going to go with the other two problems going the other direction in the next video.